Toshio Fukuda. He will discuss about embodied intelligence and robot, AI robots and future directions. Professor Fukuda received Doctor Engineering from University of Tokyo in 1977, several years back. Currently, he's a Professor Emeritus in Nagoya University and Professor Waseda University and Vice President of just his major area is biorobotics, especially micro and nano robotics. He was the president of IEEE in 2020, the IEEE Director of Division X, System and Control, IEEE Region 10 Director, and served as president of IEEE Robotics and Automation Society, and also director for IEEE Division X, System and Control, and many more IEEE societies. And we would like to hear Professor Fukuda. And of course, as a personal note, he is the supervisor of my supervisor. That is the grand supervisor. Professor Fukuda, over to you.
Okay. Thank you very much, Kipra-san, for nice introduction. I'm so happy to be here to this Wada University. This is the first time to visit your university. And this is the second time to visit Sri Lanka. I was here maybe 10 years ago in Sri Lanka. Here, at that time I was IEEE Region 10 Director, something like that. I organized such a kind of a meeting here, Colombo, okay? Hilton Hotel over there. So that's why I did it. So that's why this is very happy. At that time, I didn't come down to the south from Colombo, just stay there in the Colombo area, so on the beach. So this is kind of nice to visit here, this university here. And actually, I'm very happy to see so many professors here who studied at Saga University, Japan. They got a PhD from my former PhD student. So that's here, my Professor Kiyuchi and other professors, Saga University, then so it's a 1, 2, 3 layers, so it means like a third generation, okay? And I hope some of you, the student, be a kind of fourth generation to get a PhD from Japan somewhere, come over to Japan, okay? So I welcome you to come to Japan, okay? Sometime if you have a chance, visit us in Nagoya too. Nagoya is just between Tokyo and Osaka. Maybe Saga is just west side of Japan, but I'm central in Japan. So maybe you can pass by from Saga to go to Tokyo by bullet train. Bullet train runs about such a 280 kilometers or 300 kilometers. So enjoy. You so faster than by driving a car. Okay, so that's nice to see. Just like you can ask your such a supervisor or your professor here how to apply for those kind of scholarship of Japanese government, okay? Maybe Monbusho scholarship is a Ministry of Education, Science, Technology. There are many others, okay? Also, for those people who got a PhD, there's also chance to come to Japan by JSPS kind of scholarship. JSPS stands for Japan Society Promotion of Science Technology, okay? So you come there. So also you can ask some kind of people, advisor, directly. Hey, I want to go there. Can you support me? No. You can do that. Because Kiguchi, also they can do that. Last 5 years, I gave a lot of funding to him. More than $1 million US to him. So he could support some of you to his laboratory. Okay, anyway. So I'm very happy to be here, and I'm going to professor. I was a professor of Nagoya University, and I retired 2013 already, more than 14 years ago. So now I'm also a Waseda University professor. Also, I'm a PSA. Here, EJA stands for this one. That's it. This is a university, Egypt. This is Egypt. This is Egypt. You know, pyramid. You know, pyramid. Do you know the pyramid? 38 degree. 38 degree. Okay, not 45. 38 degree. So slope is 38 degree. So that's a kind of pyramid there in Egypt. This is called Egypt Japan University of Science Technology. It was founded just 15, 60 years ago, 2009, 2010. So I was there, and at the beginning, I was there as a founding member of the university, but 2013, there was such a kind of a sort of spring of Arab here, so there are all kind of things, kind of a revolution, something like that, sort of kind of things, and then they asked me to go back to Japan, okay? So I went back to Japan, and later on, 2002, 3 years ago, they asked me, come back to this university, Egypt Japan University of Science and Technology, in short, EJAS. Okay, so I'm a vice president for research of this university. So that's here. Okay, I'm here. Here. So this is another one. I have to walk here. So I like this one. Cartoon. I like robot. It's a cartoon is written by Japanese guy who was a medical doctor. He's a medical doctor. That's why he has many kind of a story, kind of medical thing here, less music, kind of surgery or something like that. But he liked this kind of cartoon. Okay, so that's it. He made such kind of cartoon. Then I wrote a book for him to celebrate this story about 50 years ago. 50 years ago, he wrote this kind of manga. Okay, that's a kind of manga is cartoon. Okay, so I wrote those things. What I wrote was the engineering, robotic technology to realize this kind of robot. Okay, today you can see many human robots. Okay, nothing wrong. Okay, there are many. Okay. But how we can make this, okay? That's a kind of technology, manga. Manga how to make it real for engineer people. Okay? So that's here. So that's here. Hey, that's something like that. I was a president of a multiple society, ITB, robotics, okay? Robotics are nice, we see, something like that, okay? They go to cartoon, okay? I like how to realize such a robot, okay? To do some lesson here, let's see. Also, I created ITB this new transaction, mechatronics. Maybe you might hear some of you might know what's IEEE. Those people who know IEEE, raise your hand. Oh, you know that? Oh, some programs still know that IEEE. Do you know IEEE? What's the sound of? IEEE is I enjoy eating. That's why I believe when you are kind of join the conference, you know, they provide you many foods. Okay? Breakfast, lunch, and dinner all the time. Okay, that's why I believe eat something. Okay, I enjoy eating. Okay, so if you like it, join us here. Okay, so I'll make it here. So you can make us such a kind of brunch of students got together. Okay, you can get together, or you can have a sort of meeting, sort of a party also afterward. IDP will give you all kind of support, financial. So maybe for each student members, okay, they give such a $3 per year, something like that. So if you get 100, then you get 300 US dollar, okay? So you can have a party here after meeting, okay? I mean, student branch meeting, okay? So that's good, okay? Why not? So you are member, okay? So you can ask your advisor here as a member of IDP, okay? So that's nice, okay? So that's nice. Also, division director, the rest of the maybe thing here. I actually created such a IOS conference, Intelligent Robot System Conference, 1988, when I was so young, okay? I was not about 37, 38 years old, okay? Then did it, okay? So now, today, as I tell, I want to discover 330 participants. Do you know how many now? After 37, 8, 9 years old, year later?
3,000 more than.
No, 9,000. 9,000 participants, okay? So it's grow, yeah, something like that. It's not a good idea to make a big conference because so big, I cannot attend the session. I like more like a small one too, okay? So that I created another. Here images, Roman conference. Roman is robot to human interactive communication, like a human interface, okay? So this is a more like say, reading is a 100, now it's a 500, 600, something like that, okay? So let's say in Japan, by the way, Kita Kyushu, the nearby Kyushu, Kyushu Island, okay? So the nano, okay? I created nano counts because I worked on nano robot manipulation. So I did it by myself. So I'm a founding president of such a kind of nano technology. Nano, besides system integration conference, and also means advanced robotics and social impact. I created those things here. So the size is 100 to less than 200, something like that. So keep it small, okay? And the SIA, this is a System Integration International. This year, it was, now it's going on in Mexico, Cancun, Mexico, okay? So this is the size is about 300 to 400, okay? And then I think the ISR, intelligent and safety for robotic system. But here, this is small, I keep it 100 to 150, okay? Then CBS. CBS means stand for very industry. Cyborg. Do you know cyborg? Don't you know cyborg? Manga? No? Those people knows about cyborg. Frankenstein. Raise a hand. Only two. Yeah, three. So, don't you know the manga? Frankenstein. Well, here, only here, top is a human, others, that's just a mechanical system. It's a hybrid system, biological system and a mechanical system, okay? Cyborg and a bionic system. I create those things too. But this grow rapidly. Here, 2017, so fast. This is already 500 attended. And I also created a journal of cyborg bionic system. Just 2018, 2019, okay? Well, just 6-7 years ago. Now, believe it or not, the impact factor is 18.1. Submit the paper here. That's good, okay? 18.1, just 5, 6 years, 6, 7 years. So good, successful. Good. Okay? Something like that. Also something like that, and the president and whatever, something like that. And then the PCC student 104 so far. Okay? Something like that. Anyway, that's a story. And I want to just have a kind of encourage you to make something new. Okay? So that's today's message. Do something creative, create something. IEEE. You are a member, you could be a member, whatever. So you can create many things. Okay? I create those things just when I was young. So okay, if you're a student, you can create something new, okay? To the conference, to the meeting, or with this university, you just university, you get together, okay? So you can make a branch of this university, okay? That's it here. That's nice to have those things and encourage you to do something, enjoy something else outside the university, okay? So you can advise them, give us good advice what to do, something like that, okay? Anyway, that's the thing here. Oh, okay. So my talk today is not important, okay? My talk is more just give an encouragement, you all people, young people, to join something, your activity, your kind of depending your interest. This one, okay? What you look at. So since you are electrical engineering department, you must have a wide area of kind of a thing. Some people need kind of like such a car electronics, for autonomous driving car, some kind of train system, some kind of power electronics, some people need kind of more such a kind of information science, computer engineering, or many other AI, many, okay, doesn't matter, okay? That's why. So you have to pick up one, okay? You can do that. Or you might be interested in the Patao electronics. Okay, bioelectronics, we do some here to, and I'll tell you why I'm interested in such a cyborg. Okay, later on. Okay. Today is about with AI, machine learning, you know everything, okay? It's a, I think you're working on those things if you like it, okay? It's a AI doesn't cost anything, just do by your PC, okay? Nothing. You can do anything here. Some example, what the show program, embodiment kind of thing here, and just some. Otherwise, just quickly short. I have how many minutes more?
So you can take 30.
No, 30 minutes, okay? If I exceed 30 minutes, stop, okay? Immediately, not per hour. Okay? So anyway, so here. Okay, so that's a kind of comfort space. Comfort space means what's that? You can make a kind of your AI, your kind of terrible technology, or kind of avatar technology, or many others. You can make a kind of a system. So what here? So like here, when you be at the hospital, right? You need a, you don't know where to go. Because hospital is so big, okay? Where to go? Use some guidance, okay? Some guidance here, okay? Then if you get guidance, maybe robot come here, maybe you can ask somebody, you have my better something here to solve me. This is a kind of avatar, okay? Avatar is something adjoined to you, okay? Something happened, you are in trouble, you have some question. Give me something, what to do? Boom, come up here, pop up here. So tell you what to do, okay? What shall I do? Okay? That's like that. Okay? They can help you, okay? Something. Or something. You are sleeping or somewhere. I need some good sleep. Need some such a case that can control all things here. And the lighting, temperature right here. Room itself is your robot system, okay? Room is space is your robotic system. Another here, that's a kind of ubiquitous information wise, in your office, your outside, inside. Somebody inside, somebody here, you, they're like a sector robot here. What should I do here? Today, you can ask the robot, hey, help me. Siri, you can help me, okay? Or you can say that the chat GPT, what can tell you, they can give all solution, okay? But don't believe them, okay? 100%. So they are telling you something wrong, okay? Don't blame them, okay? You can believe only, say, like 60, 70, 80%, okay? Not good, just judge it by yourself, okay? Don't believe 100%, okay? So then that's the answer. Then you big down, yeah? That's a here, we can do something like that. Then also, at home, here, you are inside or outside, okay? So if you're here, family wise, there's something here, robot come up here. Hey, what you do? You should pray, something like that, something like that, together, or in over outside, and here, and surveillance, for your security, safety, something like that, you have something like that. And when you're driving your car, it took 1 hour from Colombo to here, or in some case, and tell you, oh, you want the radar, you want to go here place, you want to go here. So now they are giving such kind of information. Okay? Why did you take a rest here? Wow, I was driving. Enjoy it. Oh, here, you have something what you like it here. Okay? Something like that. So that's the kind of here. So that all things connected. You can make a comfort space. When you're driving a car, your space is driving inside cabin. Okay? So they tell you what how do you make it, how you make yourself to be comfortable when you are at home, you are with the family, you can tell you how you can make your life happy. When you are kind of laboratory is a university, how you can enjoy your research work or your studying with such a kind of system. That's a innocent, okay? Anything, comfort space, even university. When you're here, how you can make this kind of comfort space, okay? Or even like a Colombo, you can make a kind of system comfortable. Even you are kind of Sri Lanka country, so maybe those in white or something like that. Anyway, that's a robot 4.0, 5.0, 6.0. Today, it's a 4.0 to 5.0. In the future, 2020, 2015. Maybe 25 years later, maybe it's robot 6.0. More intelligent, okay? So, robot theory, what to do, something like that. So, question, what you are going to do? Well, robot is smarter than you. No way, okay? So, you have to study a lot. Don't be a slave of a robot, okay? That's important. Important message here, the similarity. So similarity means robot intelligence is much smarter than human. Okay? This university student, clever, smart, they study. I don't want to slave of robot. Here, study more, okay? Here, higher level, okay? That's important, okay? That's why you have to be smart. When you become 50 years old, don't be a slave of human robot, okay? Okay? That's my message today. Study hard, okay? When you are young, okay? Yes. So this is my story, what I used to work in my career. But here I work with such a normal system here, also here. Okay, it's a non my this is kind of here, so make a medical robotics here. Then you can make about monkey robot. Monkey robot, how we can robot make those in here, so clever, and such a thing. And then here is many robots work together. Many robots. So like here, you can work 3, 4 people, 100 people, 1,000 people, swarm robotic, how we can make it something like that. This all kind of thing. I work with those things, but there's a very simple to work this area. That is why what's most important thing is just control feedback. That's all. That's simple thing. You just think about some kind of a phenomenon. What's happening here? Micro, nano level, just atom level here. Then atom get together, make it here more cluster, make it organ, make it more, put it here, many, okay, many together. That's simple. Just control communication and feedback. That's all. Okay, if you think about nano, just think about, just say, think about, just say such a phenomenon, nano world, okay, nano world, something like that. That's all. Why you just go over there? Don't worry about it. If you have nano or big one, if you write a differential equation, same. It's the same, just like the differential, same, nothing, okay? No problem. Okay, that's a good book. Some those things. When the song about here, we can write about here, here, many robotics, and here the second of my program. For me, as an advisor of university, okay, so simple. The student come to my lab, I ask them, what do you like? This area. So they chose some one of them. Okay, go ahead and do that. So what I do is just then intermediate, then the last one, just last semester, end of semester, I ask them, what did you do? That's all. My control, the student, is so simple. Nothing, okay? Just they do by themselves. Okay? So these are I give us only motivation what to do. Do as you like. Okay? That's simple. Okay? That's so nothing more. My students love it to work. Okay? That's great. So that's the intelligence. Okay? Multi-scale robot. I made those things in 1994. Long time ago. What's important? Just imagine individual. How the intelligence come up? You are intelligent. You have to smart, right? You have a brain here. That's here. Something like that. You have intelligence here. They come up here. If you get together, 2, 3 people get together. In US, double head makes a very good. Okay. In Japan, 3 people get together. They are getting stronger. Okay? Something like that. Then come up here. Many people get together. That's a kind of intelligence. So new intelligence come up here. So that kind of so like kind of social human being or colonial social insect. You look at the ant or bee. How they make such a kind of system by themselves with a kind of small brain. Okay? That's great, something like that. So that's here, do that. And so also saying important self-organizing robotic system. Self-organization is very important. Self-organization. Self is nothing special. You do by yourself. Your brain was doing self-organization. You are working neural network. It's a self-organization. Everything is self-organization, okay? Nothing new. Just simple. Just self-organization. Okay? That's here, it goes here. Make a video here. Just, think about some what to do, right? So that's here. Oops. So, like, the robot, my friend, Mark Reber, my good friend, since 1940, okay? So, good friend, okay? I work with such a kind of brachiation robot here. The brachiation kind of branch moving around, okay? He working with hopping robot. We are the good friends, okay? What I can start with the problem, what, some of those things, many times, okay? That's nice to see. But anyway, many people like this one. With robot. Yeah. No voice. Voice? No voice? It's okay. Some music there. Anyway, he's a Boston Dynamics. He was a professor at MIT. Make those things. You know this video. Also like kind of a robot marathon, human robot in Beijing. And speed, top speed is 8 kilometers per hour. You are much faster than, okay? Don't worry, robot still behind you. You can run much faster, right? You can run 20 kilometers per hour, right? Maybe. When you are driving by bicycle, bicycle speed is 20 kilometers per hour, okay? So that's here. So don't worry, still is slow, getting faster, okay? Anyway, this is a marathon here. So around only half marathon, 20 kilometers, okay? Then here the speed is 12 or 40 minutes, okay? Because so slow, 80 kilometers per hour, okay? So don't worry, you can run. You are one full marathon, twice more, okay? Then you can run 2 hours, right? I mean, top runner, Olympic game, okay? Top runner, gold medal, 2 hours, 4 minutes, okay? So anyway, boxing. That's the kind of thing. And among them, did you notice something? The reason why is that hopping robot here, they don't interact with the human. Again, this is important. There are many people, like an American guy, they are so, I don't say they are stupid, but they don't know such how to make kind of human robot. They make a robot, many companies are making such a kind of a human robot. They don't interact with the human. Okay? That's a robot, okay? We always make a robot to interact with the human. Okay? So here, what's the one? Take a look here. What's the problem here? Like a medical doctor, take a look. What's the problem? Like that. Here, okay? That's a robot we want. So I myself work with Honda Asimo robot. Last more than 20 years. The human robot. Okay? We know how to make such a human robot. Okay? Anyway, that's something here. Anyway, that's here and before I already know the micro robot. Well, okay, how do they get together? Reconfigure. They can change it from form if they like, okay? You like a manga. Change it for form. Okay. Okay. Because I like kind of manga. Ultra ball, okay? That's why from manga I got the idea by myself, make such a robot. They can change the structure by themselves. Okay? But that's all like here, that's any man-machine system is always one-to-one. Okay? One-to-one. Robot here. Then maybe if you are working in medical areas, medical engineering, something, unfortunately, they lose arm or leg here, then we have a kind of anthropomorphic arm or leg, okay? Like artificial anthropomorphic here. So we can handle something like that, okay? Or something you lost the leg, so here, heart, you lost the heart, put the heart over there. Today, we can do that artificial, okay? So then we can like change it, cell level, something here, change it the cell level, okay? Let's say possible today technology with medical areas. So we can have such a robot, micro nano robotic system to do so. For that here, also like kind of many robot, 3 robot human together, we can hold and see here, okay? That's all okay, you can do that. Or even this one. Maybe you can work here or Colombo, somebody in Colombo, work together. Or US, Japan, no problem. You can work here. Today is here more, okay? Something like that. Like a kind of a telemedicine, some of them here, okay? So I like this robotic system. Many robots work together. Then I wrote this one, 1994. Why? I helped the funding agency, United States, NSF, National Science Foundation. They asked me, Toshi, which field they should fund me? Oh, really? I give this picture. They are very happy to get it. And they funded those areas. Okay? This is the base of the NSF funding policy, okay, for these robots. What's it? Robots just one piece. Okay? What's important is more interdisciplinary work. Okay? Interdisciplinary application here, communication, self-organization, of course. I love self-organization, chaos, fractal here. Synergetics, that's important to do so. Here, after life here, graph, emotional biology here, sociology, economics, game theory, operation research, optimization, particularly if you do some optimization problem, you end up some one, okay? And also computer intelligence, AI, or computer intelligence here, or some reason here. That's very important with the human interaction. Okay, that's a thing. Don't think robot is not one thing. No. Everything here. Okay, so you have a lot of space on such a computer side. Today, if you work with a sort of robotics, you have to work with such a kind of material science too. Okay, material. There's something like that here. So that's a kind of not human, robot interact, information-wise, or physical interaction. That's why I like the robot. With the interaction, like here, interaction, okay? That's not only information. You can shake hand because, physical interaction, okay? So some areas that I like, embodiment, intelligence, and robot. Why such a person can symmetric, robot human, is symmetric 2050. Symmetric means human, robot work together, okay? You can hold each other, okay? So today is not symmetric, not symmetric. Human have more intelligence, while robot have more kind of labor work, something like that, cell-wise, is more powerful, okay? Remember, because memory, we forget quickly. But robot can never forget, okay? Memory, okay? So that it's not symmetric. We want to make those things symmetric, 2050, okay? Something like that here. Human make a robot, intelligent robot, make kind of a human more intelligent. We learn something from here. So we have a medical process here. So that's a spiral up there. That's a kind of effect with a wide interaction. That's why embodied AI and cognitive AI. Today, many people working AI, they are very interested in AI. Okay? But the big difference between cognitive AI and embodied AI is different. So when you work with ChatGPT, you are working this area. Okay? When you work with a robot, you are working embodied AI. That means physical sense that come up here. Also, you have a kind of your intelligence come up here. Okay? That's a different. Okay? Think about the consciousness. They don't care. They care about those things. Okay? Awareness, important. This here. So also human collaboration. Intelligence manufacturing wise, if you're working, maybe you need some here. Human science, is here. Take care of that. People here, also new finding a solution. Make this is important. You can make many experiments. Okay? To find some material to find some kind of solution, something like that. But you make a lot of experiment. For example, IBM, 7 years ago, they made an experiment a lot to find a new material. It took 6, 7 years to find one because of experiment, trial and error, okay? Trial and error. So, but today, we should make it shorter, within 1 week, what we can find it. That's it. So, that's nice to find those things, okay? So, also, so on. One person cannot make it a lot, but if 2 people, 3 people, maybe they can make a good one, okay? So that's good. So that's here, maybe emergency. Something didn't come up here, okay? Something key up here. So when you write a kind of proposal, you student application to some university, you just keep such a keyword here. They are like such kind of thing today because of such a kind of AI all the but you have to write some what to solve problem, something like that. Okay, so anyway, that's important to do so. So then I tell you what the moonshot. Moonshot program was kind of go to attract the people and promote the challenge around the project with the aim of resolving different societal issues by bringing together the research from all over the world. So this is a kind of joint program, 5 years. So since last year, I did it, 5 years. And while I did it, I spent 250 million US dollars. It's a lot of money. That's I don't care. That's not my money for government. Okay? I spend on me a lot, 250 million US dollars. Recently, one of my the person who received the funding because he was my PhD student. I give him, okay? So I do work. I don't care. Spend money, okay? Just give money. Make some research for 2050. Not today. Not today useful. Not useful today. Maybe later. 10 years later, 20 years later, 25 years later, maybe useful. That's a technology. We funding, okay? Come on. We cannot make a kind of useful one just take 5 years, okay? Take a lot of time. So that here, the challenge. Make a challenge here, intelligence. Intelligence can act with human being. That's important to do so. Though I spend some money here to do so. Okay? This is important to do so. Importance is such a concept. Okay? Some people don't like a concept only. They need more kind of practical thing. I don't care what the real result is, but I just have a good idea. Okay? Somewhere here. So that's here. Like my idea is here. Robot come up, human was born. Okay? Baby here. Then grow here, here, boy, studying in the university, here, working in the company, right here, and later getting old, okay? Then later, maybe 80 years old, 90 years old, 100 years old, 120 years old, maybe grow, aging, then die, okay? So from cradle to the grave, you can take care of them, okay? That's something like that here, okay, that's it. Also like here, or here, robot here, working together, okay? Robot human to work together. Here, if some disaster happen, or robot goes there, help to be too much rain, so the go was here. Or sometimes we help people to go to the moon, okay? That's a space. They come up here, this is here. So this is some here. research work, find some solution, good solution. Okay, some solution. So do some research. Okay, it's a moonshot program, and what I did 5 years. First of all, embodiment important. Okay, physical AI interaction with human. That's a top goal. Okay, top goal here. Then top up here. Then what I need is a next AI, next robot. That's the one. Tell me what's the kind of next robot, next AI? That technology, something here, okay? From component sensor here. I need everything. Physical, legal, is something when you make a research work, you have to mention at the end of your application. Okay? It's important. You just say you are my robot so good, but at the end, you have to tell is a research proposal. Always say everything. Important. Ethical, legal, social impact, social standardization. If you write a proposal, needs to something like that, others they don't accept your proposal. Because when the robot is okay, 2050, who knows, robot will be accepted by the society. Maybe too old fashioned. That's it. Neither always is okay, acceptable, not. Always ask me every time, okay? It's so sad. After 10 years, 20 years, 25 years later, research work, my robot is not useful. Bad. Okay? That's what you have to always think ethical, legal, okay? That's important. And I gave also the money to them. And also Waseda, he made a medicine robot. Okay, here is like washing toilet. So here, here, shoes, socks, wearing socks. The guy need to just give you a leg. Then give you socks, okay? And here, okay, and over here, it looks like that. So like something like that here, like that. Okay, that's also disaster handling. Okay, okay, something important here. Software robotics, software robot. But why you keep it? Must be rigid to hold the people. Soft, okay, yeah. But here, the other must be strong to lift 60 kilograms or 70 kilograms. Bang up, okay? So that is here. Another one, we then exhaust here, and main robot together here. The main thing. Any those here make a robot. Other kind of a scientist. You can be a scientist every time with a robot. Will tell you what to do. Okay. So next here, what experiment? This is the best condition. Simultaneous injection, something like that. Okay. That's nice to work together. Oh, coevolution, human and AI robot, preparing with everybody's can be science. Eventually, with this robot, you can be a scientist. Maybe you can get a Nobel Prize. Look back to 1 year, 2 years later, they got the Nobel Prize. One guy, physics guy, we're using AI. They got the Nobel Prize to find something new. Okay? Last year, hopefully, all 10 people received the Nobel Prize just because of fooling here. Okay? That's great, good. Maybe you are doing something else. Nobel Prize, you can get Nobel Prize. That's areas here. Important, make a hypothesis. Like here, design how to make an experiment. Then experiment by robot. Okay? Then observe it, get the result, analyze. Okay? You do by yourself, but robot will do that. Okay? Then what to do next? You put a theory. Okay? Theory. New idea. Here's some, there is another one, another experiment, make a root. Okay, that's good, important. So that's here. So another one, this is the one by heart. That's the kind of main thing here. They make such an experiment, okay? Many of them work with, okay? Another, just added more like a space program. Put the moon. How can go to the moon? So I found those things here. Put the key inside. It's not kind of easy to go. What was there? So in key, okay? So also that's here. Main robot, jumping robot here. Main after giving the 30, 40 robot here work together. Okay? So when you hear some, you should find something new. Anyway, that's a robot here. Good. And also we need some space to live. Okay? Space. This is something where you can live. Yes, sit there. It's a moon. Okay, then that one is moon. Okay, intro. Moon. Okay, rolling by themselves. So this is what I see here. So also like the World Expo last year, Osaka, Kansai, we had the World Expo. We had this we showed those in our experiment with those people here. And they are very over there. Here. And finally, this is one. This is a computer with self-assembly. Okay? So reconfigurable. This one depends on task. They make their own robot. Okay? That's good, okay? So that's nice. That's here. Anyway, important I like that's not only making such a robot hardware system. I like more of the awareness science. Awareness science here, if somebody here would help, who was there without being asked by lady. Okay? You're gentle. You can help the lady. Okay? Okay? Or somebody here is the person who has some problem, and we can help him or how, okay, something like that. Why I had such an idea was 1996. I was in Spain, and I was walking some streets in the rural areas. We had a kind of scientific meeting of the council. In the morning, I was walking 8 o'clock in the morning, and some already showed a kind of gesture here. I don't know. He said, it's like I'm alone here walking. And there, what? Lady said, she wanted to go to the post office. Okay? Post office. But there's a step, 1, 2. Only 1, 2 step. So she will, I don't speak Spanish at all. I understand. Just she wanted, I need to give her my shoulder to her. Then she can do some more. Until then she could succeed in going to the post office. Okay? From that experience, when I was young, that kind of experience, important is awareness. Okay? That's my personal experience. From that personal experience, I like this idea, and that's why I need to listen. Right? Meta-knowledge, intention, understanding what the lady want to do. Okay? But here, there's consideration, sympathy, respect for people. They come here to get this sense of awareness. Okay? By the way, you can write a proposal here among this one. It's very advanced. Good. Okay? You can get something. Before American guy, European guy noticed something, okay? Our biggest number, they don't care. They are They have different mind, okay? We should be pioneer in those things, okay? Different, okay? But the importance of it, so you can awareness and something like that. Maybe you are with a brain side, okay? But wait, just use it, just apply AI, no, nothing. I have no need that. Born here, like that. Then come up here, AI, another AI, they awareness inspiration, but that inspiration important. You are smart people. You have some inspiration. Inspiration important. What to do? If you're here, make this one. You have an associated memory. I did something like here, similar one. Maybe I can find this one here too. Oh, you have some experience. Something different scenario, a different place, but you have something here. That's important. So inspiration. So also, if you write a proposal, inspiration fired. Good to know, because most people don't know. They are not so good at inspiration. How we can make inspiration? Okay, that's here. Human factor wise, social factor wise, the make sense here, big here, inspiration, the make abduction. Okay, abduction. If A and B, then we can see. Okay, something like that. We can get it. Okay, so that's why AI today people are talking about AI. Now you are important people. You are smart people. You have to go advanced than those people. That's a kind of Silicon Valley. People in Silicon Valley, they are interested to make money. But today's AI, I'm not interested in that. I'm interested more in advancement. Go to the AI, automated AI, automated inspiration. That's AI for me. Automated inspiration. It's a kind of sense here. Okay? That's here, you can make it here, you make against AI, if you inspire AI, you can multi-modal data, you can inspire the Prof. This is important to see. That's why that's awareness consciousness. Important. If you let the consciousness, maybe we can find not so many proposals. Maybe a couple of proposals. France, maybe from one or two of Germany, US, maybe some, okay, not less than, not more than 10. About proposal, read a proposal. But in most cases, they are more like conventional, it's okay, we can imagine so far, okay? But the other important to think about, that's kind of cognitive modeling, attention, recognition, and consciousness inspiration. If you have such an idea, you are a top runner in this field. That's important to do. Okay? So this is so simple. Everyone can do that. You can do with a PC, no problem. That is, you can do that. Okay? So, like a John and a baby here together, working here, we get the robot AI, this is kind of a, this are copy here, also here, this is here, that's here, they want to. So instead of him, instead here, they talk to each other. In Corona days, very important. They can meet each other. Of course, we can Zoom, okay? But make something here, so they can communicate here instead for you, and say something kind of a copy, okay? So then you have a good communication, maybe make a lab, maybe not good, not successful, okay? That's a bad, okay? But today, multiple agents from the past, present, future, for the self, partner, counter, and others. You can talk with your grandpa, grandma, who already passed away with a picture, okay? With video. Today, we can do that. And I taught those things 10 years ago, but Chinese people did it. They created such a kind of software. That's nice. Talk with them, okay? Anyway, that's here. Awareness, what system here? Oops. This is one. That's here. Some people here, medical here. The medical will do that. Okay? Anyway, important kind of cyber. Cyber kind of hardware system here. So here, computer memory, it's all main, okay? So don't worry. Here touching sensors, okay, here sound, here devices touching, both energy and the organ here, or you can make the kind of supervision system here, or you have your pass here, here. Again, what important? Neural connection. Neural connection, right? That's important. That's here. That's when robot, mechanical system, and creature animal have a kind of fusion. That's a cyber. Cyber is here, making such images, such as cell level, micro nano areas, measurable, make something missing here, or total system. If you are interested in control system, you work here. You're interested in bio, here you can work here. You can only interested in here, so you can do that medical area. Okay? So that's the case here. This is cyber, not a human, but a cockroach. Here's a cockroach. Okay. You know the cockroach? This one. How big is it here? Is it big? How many centimeters? 5 centimeters?
2 centimeters.
2 to 3?
Yeah.
Oh, in Japan is also 2 to 3, small. I like a big one. The reason why I put something on the top. So we took those things from Madagascar. Madagascar, the cockroach, 5 centimeters big. So I can put something on the top. But, okay? Okay? Big one is better for me. But I can do human being, right? Better. So a dog, no. There's also put the kind of cockroach. Then cockroach to the air. And you control the right, left, reverse. So we can control cockroach. Okay? Give a signal to there. Right, left, good, up, something like that. So do that some here, control, so that make cockroach. Big part, okay? That's what you're moving. That's what you're now, technology advanced. Make it small, micro. I put it inside here. Inside. Okay? That's small. Then the other thing here, we are ready here. No piggyback. Everything inside. This is all PC inside. Good, eh? It looks like just a normal one. Normal cockroach, but not here. No. Here, you can see, right? Really on. Here, but here, left, right, left, okay? So cockroach move this way or this way as you like, okay? Okay? So here, this way. So here, the cockroach is but cockroach is just over here. We put the cockroach in the water too. Water, also space in the moon. Moon, there are no air. Okay? So we made a certain kind of capsule, okay? Capsule. This is a capsule of cockroach. Cockroach capsule. Okay, the cockroach is here, so that's here. So also cockroach and putting some kind of a part here. Okay? But that's it. So I found this one to the Singapore. The Singapore guy did those things. Okay? I like it. Anyway. I like this one. Basic. What's important is something like embodied robotics, but like more such a kind of something new idea. Okay, new something you like it, and some kind of what you are learning, okay? Which one, something, some kind of curiosity is very important. I stop here, but I had a lot of curiosity, many story. I wrote a many story about those things. How that I can get up some idea of micro nano. I created such a micro nano area as a pioneer. Micro nano robotics. You can check my name. Or recoffee robot. Robot here change the structure by myself. You can check the Wikipedia. Self recoffee robots. You can check my name here as a pioneer. Somebody needs something. What you just a kind of curiosity. Important. I saw. That is it. And I think that was he knew because he also has a curiosity. Up drop on the ground. He is not hungry. He just wild up drop on the ground. If he's hungry, he just eat it up, okay? Curiosity is important. So he was such a place. A mental sleep is okay. That's very interesting. No great discovery was ever made with a bold guess. One more thing, what he said, if I have seen fathers and others, it is by standing on the shoulder of giants. So means all the research going always learning. We are always learn something from the past, okay? Get some idea. That's the kind of science means. You have checked some conventional papers, what to do, what the people did, something like that, and to find something new. Okay, anyway, that's my story and my message to you is that don't be afraid. Be a student, nothing to lose. Well, what do you think? So good, okay? When I was a student, I went to US to study. After that, back to Japan, I went to Germany. What's that? That's something, okay? Don't stay somewhere. Have some good idea somewhere to interact with other people. That's my message to all the professors here studied in Japan. Good idea, right? So that was their elite. This university. You look at, you have that good example, right? Do something like that. This is a message to you, all students here. Enjoy. You are studying here. You are eligible to make a research here. Thank you very much.
Well, thank you very much, Professor FUKUDA, for nice talk, inspiring talk. So I'd like to invite the direct visit of University of Morelos to hand over to open our application to Prof.
Yes, thank you.
So thank you very much, Professor FUKUDA. So this ends the first visitor talk of the Tagalog Language Studies for 2026. Thank you very much.